Hey, what's up? Okay, this is page 110, chapter 3.1, question 3, A and B. So a person is standing in a subway train holding a strap that is attached to a piece of luggage on wheels. The mass of the luggage is 14 kilograms. Mass is 14 kilograms. Okay, the strap makes an angle of 35 degrees to the vertical, as we can see there. Assume there's no friction between the luggage, wheels, and the floor. Determine the tension in the strap when the subway is moving at a constant velocity. Okay, well first I'm going to redraw this little picture. So here's our luggage. Here's our strap. This is 35 degrees. Oh, it's really little. There it is. Okay, so determine the tension in the strap when the subway is moving at a constant velocity. In order to find tension, we do F net equals MA. So we know that, what is happening here? Okay, we know that our mass is 14 kilograms, and we're looking for the tension, which would be this value. And this is when the subway is moving at a constant velocity. When something is moving at constant velocity, if v is constant, that means the acceleration is 0. That means if we were to do F net equals ma, we'd be doing 14 times 0, which would just get us 0 newtons. Therefore, the net force, we're looking for force of tension. So the force of tension, let me say that instead, is 0 newtons, because it's at constant velocity. Constant velocity means no acceleration. 3b, determine the tension in the strap when the subway is accelerating forward at 1.4 meters per second squared. So we know that our mass is 14 kilograms. And now they're telling us that the acceleration is 1.4 meters per second squared. I'm going to redraw our picture because it's pretty important for this question. So here's our little picture. Pretty little again. 35. So if we were to do F net equals MA for this question, we'd be doing 14 kilograms times 1.4 meters per second squared, which would get us, just calculated this, 19.6 newtons. And that's our F net. That would be fine if this was just a straight line, or if this was actually the F net. So what's happening here is that this F net, well, first let's look at this picture. Here we have a angled tension, which means that we have an X component and a Y component. The Y component we know is being canceled out by gravity because the suitcase isn't moving up or down. So the forces in the Y direction are equal to 0, which means that the forces in the X direction are the F net, because this suitcase isn't moving up and down, so what we really just calculated here, the F net was this X value. That was the F net. So if we look at this diagram, this is opposite of the angle, and here's the hypotenuse, which is our tension. So really, we could write this as opposite over hypotenuse is equal to sine theta. Here's our theta, here's our opposite, here's our hypotenuse. We know this x. We know that this x is the F net. We just calculated that. So the opposite we know is 19.6, this F net, 19.6 newtons over the hypotenuse, which equals sine, and then our angle, which is 35. Yes, sine 35. So if we want to rearrange this to find the hypotenuse, because remember the hypotenuse is our tension, we would do hypotenuse equals 19.6 over sine 35, which gets you a hypotenuse of 19.6 by sine 35, 34.2 newtons. Therefore, our force of tension is equal to 34 newtons. And there you go. See ya.